Classmates, just now, we learned about construction materials, including the selection of design mix ratio and the calculation of construction mix ratio. Next, our task is to log into virtual simulation system developed under our school enterprise cooperation and simulate course project Aliquar Dam, a 13 block from Pakistan. Conduct a mixing simulation. Classmates have got the drawing of. When we conduct the mixing simulation later, everyone should review the drawing carefully and operate according to the characteristics of the block. Next, let's begin the first step of the task. Complete concrete material list. Please each group leader assign tasks. And then we start.
No objection. I think I should also express my opinion in the debate. It should be according to 195. But there is still water inside number 40 on site. If he doesn't cut it. Teacher,
What's the matter?
our group has different opinion about the water usage. They said to calculate directly according to 195, but I think we should subtract the water content of 41.3.
How did you think?
Because the site uses gravel that contains water. If we don't consider such moisture content, it will change the mix ratio, thus affecting the strength of the concrete.
The analysis is very well done. For this knowledge point, I have covered the topic during the last class. It should deduct the water content of the sand, otherwise, it will affect the concrete. You can review it again.
Okay, you see, I said that we should subtract such weight. There are 3 options here. Which one should I choose?
We should consider the characteristics of the block. What is the spacing of our steel bars? Have you seen it? Drawing.
On the drawing, it says 40 millimeters.
When we select the mix ratio, we need to consider your aggregate. Can it pass through the steel bar smoothly? Please check the specifications again, then decide which one to choose, right?
Okay, I'll look up the specifications.
Fourth group completed.
Okay, all groups have finished, right? Which group would like to share their result? We chose the classmates from the second group.
This is the result of our group. We found that according to the engineering drawings, the strength of concrete on the A13 block is C30, so we chose MP45.
Thanks for sharing, second group. Do other groups have different opinions? Yes. First group.
Teacher, we are using MP46 mix ratio.
Come and show your result.
This is our group's material list. We chose mix ratio no MP46. According to our group discussion, we found that the rubbers on A13 are very dense. Minimum spacing reaches 40 millimeters, and MP46 only use gravel stone. It can fall into the rubbers perfectly. There will be no cavity phenomenon.
Do you have any basis?
Classmate, in the book titled Construction Specification for Hydraulic Concrete, there are clear provisions on page 49.
Okay, do other classmates have anything to add?
No.
Back to your seat. The results provided by. These 2 groups are different. Which group is correct? Let's start by watching a short video. The content presented in this video is the rebars arrangement on construction site of A13 block. You can see, the steel bars here are very dense.
Yes.
Okay, for MP45 and MP46, although their strength levels are the same, but their specific materials are not quite the same. In MP46, it only uses small coarse aggregate. And it has a large slump, more suitable for use in areas with dense rebars. Therefore, the reasonable configuration number for A13 block is MP46. Good. The group that chose the wrong option should correct it quickly. The teacher want to reiterate here, regarding the water usage in the construction mix ratio, we should subtract the water content of the sand. Otherwise, it may result in slumps not qualified. If the slump is not qualified, the concrete is not qualified. Prohibited for use in dam construction, otherwise, it will cause quality issues. Okay, about concrete material list. Anyone have any other questions?
No.
Okay, next, we can enter the second step, measure and weigh. For weighing measurements, our specifications has what requirements? Please classmates refer to the specifications to fill in above content. The task has already been shared on the big screen. Please each group assign roles. Let's take a look. Which group completed the task first? Let's start now.
Our 2 departments and 3 industries should be 52 pages. And the clause is 7.2.2, I think. Teacher 5th group completed.
Good, some groups have already finished. All the classmates have finished. Let's take a look at which group's results this time. Which group was the fastest just now? It seems to be the 5th group, right? We will now look at the 5th group. Let's take a look at the research results of our 5th group. About measure and weigh. We have made regulations on the measurement deviation. First, what is the unit of measurement? Kilograms. And the deviation allowed for liquid and powder is plus or minus 1%. Good. Aggregate is within a range of plus or minus 2%. The inspection of the equipment should be conducted at least once a month. Let's compare and see if they are all right. Okay. There should be no problems with the other groups. Classmates, the speed and accuracy for this review is improved compared to the previous step. After specification, let's log into the virtual simulation system to perform operations of measure and weigh.
Like we enter the third step to weigh. Or it could be 22%. His main approach to design is to try it and see if it's not right. By the way, and now let's take a look at this action.
Report 4th group completed.
3rd group completed.
All the operations have been completed, right? Please have the quality inspectors from each team perform a cross-check. Is our measurement error within the allowed range? Okay, everyone starts to take action.
Report, no problem with any group.
Okay, please return to your seat. Classmates are done well in the step of measure and weigh. The teacher emphasizes here. If the weighing of any materials of concrete is out of control or missing match, such concrete will be treated as unqualified. Therefore, when measure weight, we should achieve excellence. Okay, we have completed the concrete material list and conducted control of measurement errors. We can proceed with feeding and mixing. Which classmate is willing to come up to demonstrate the operation of our feeding mixing box? We will give the opportunity to the classmates of the 3rd group this time.
We have reached the 3rd step of feeding mixing box. First, feeding according to the material list just now. We use gravel stone, sand, cement.
What else is used?
We also use coal ash, and then water and additives. Click OK to proceed to the 2nd step, start mixing. We can see that the aggregate is transported through conveyor to the transition cabin. After entering the transition cabin, it will enter the mixing body Taj, there with the other materials for mixing. After mixing for a specified time, high-quality concrete was produced. Finally, the mixer truck can transport these concrete to the dam construction site. Teacher, my operation is finished.
Thanks the classmate from 3rd group for the demonstration. Have all the classmates seen it clearly?
Yes.
Good, classmates should now log into the virtual simulation system to complete the feeding mixing box.